Today, I'll give you a second to absorb this slide. I say absorb, but I say don't belabor writing every word down, and keep in mind as usual that the PowerPoints are online and the videos are online and all that. And this is like a direct copy of what's in the textbook. I think, would you agree that as you look up here when we're talking about transformations, that these are things you know? So don't write down what you like. You don't need to write down something you already know, maybe. That's fine. The only thing that's somewhat maybe perhaps new on this slide is this little last line down here. We write this concisely as this little column of two numbers, A, B. And the only reason I introduced that is, even though it kind of muddies the water, is because it's like a notation ID would use. Okay, so A, the top number, will be a left-right move, depending on whether it's positive or negative, and the B value, the one below it, will be an up-down move, depending on whether it's positive or negative. It's just a really succinct way of saying, boom, here, translate the graph like that, boom. Don't write down everything on there. I'm just going to give you a few more seconds to look at this. If there's something you have a question about, please, of course, let me know.
Where's the last one?
No, it's not fraction. It's just the notation that they use. It's like stack. There's no fraction bar. Just stack inside of parentheses. Yeah.
So like when would they use that?
Like this. Well, here, I'll show you in a second. I have a problem. So, yeah, I think in the problem I'm about to give you, it's like 2, -3 in a minute here. And so what does that mean? That means 2 right, 3 down. That's all. So they'll say translate the graph of this by that. And that's all. The next little piece of conversation I want to have to make sure everyone's clear on is, I don't know what your background is with transformations, but I do sense that a lot of times people think of this one in particular. This one nobody has like an intuitive problem with. But it seems like there's an intuitive barrier to understanding this, perhaps. A lot of people say, I think about what makes sense, and then I like do the opposite. That seems to like not be a place to rest as a mathematician. You should like always settle on something that makes sense, right? So if it doesn't make, right? So this should just plain make sense. Let's see if we can make some sense without, I have a little bit of a, I don't know if it's help or not, maybe you'll like it, maybe you won't. But I think that's maybe, we should never ever land somewhere where we're saying like, oh, we'll just do the opposite of what makes sense. This is a sense-making discipline. That's like the only goal of math class, in fact, is like to make sense of things. So that doesn't seem like a healthy place to land. Yeah, exactly.
So for A, which is the right or left, do we write it the same way we would in a function where a minus sign means you're going it's more positive?
No, it just means, like that means 2 right and 3 down. No example I wrote there. 2 right and 3 down. Yeah. All right, so here's my little description. See whether you like this or not. Okay. So here's parabola, y equals x squared. Here's the table. No surprises yet. And I'd like to accomplish translation 3 units to the right, and I already know you guys, because you're well versed in your algebra 2 skills, already know like the answer. But I want you to like think about the fact that, well, how would you come back to that answer if you pretend like you don't know what the answer is? Okay, for a second. Clearly, the picture we want is this one, where these 5 points get mapped to those 5 points in red. The first question I want to ask is, what doesn't change in this transformation with each of those 5 coordinates? Yeah, the only thing that doesn't change about those coordinates is the y value. You still want, so let's do that. In the table, the new table for red, we want the y coordinates all to still be the same. Do you agree? Okay, so what about the x coordinates though? What are we doing if this is what we're doing right here, moving 3 to the right? What do we need to do with all the x coordinates? Which is it? We need to add 3 to all the x coordinates, don't we? Negative 2 needs to be, where is it now? The point negative 2, 4 needs to move 3 to the right. Right? So it needs to be at, where is it? 1, 4, right? So all right, do you agree that those are the red points? Okay. At no point is there anything that's not intuitive yet, right? Of course this makes sense. Of course this makes sense. Now the only thing left to fill in is what's the rule? Now we have to think hard about this, but I think we can do it. Here are all the points we just got. What's the new rule? Let's think about what we have to do to each x value here. Before we square it, notice that what we need to do is we need to kind of recreate this situation. We need to have 1 pretend it's negative 2. We need to have 1 act like it's a number that's smaller. By how much? Oh yeah. Maybe we need to take all these numbers. In order to still be able to use this rule, we need to apply like a filter on the front, don't we? We need to take all these numbers and make them all 3 smaller in order to generate these, still get the same outputs as if we were 3 units to the left, right? So now we'll write that finally. I know that you know that that's the rule. But just verify that this works in your mind, that this makes sense. The way I like to think about the question is what happens to the x coordinate, right?
Yeah, but now I realize.
Yeah. So what is this? Why does this make sense? The way I like to think about this, the things happening inside here, is that you want x to act 3 smaller than it. That is, you want to if you're acting like something that's 3 to your left, then what are you with respect to A? Aren't you 3 units to the right of that thing? So if this is acting like a number, what negative 2 would be doing, well then that means that we must be 3 units to the right. That means we've done it, right? We've applied this kind of filter on the way in to make sure that points over here are acting like the ones they would be over here. I don't know if that's good or not. That's all I got. Okay, go ahead. Give it a try here. Keep in mind that you don't necessarily know what these graphs look like. Maybe your visual skills might be impaired on this, but you can still do this transformation, can't you? Do the translation.
Mr. Chase?
Yeah.
Sorry,
Yeah.
so the top means to the horizontal, and then the bottom means like
I'll write that up here again. So the point of this is take that graph and move it 2 right and 3 down. Don't get caught up in this. This is not the important thing today. Just do that to this graph. So take v of t, move it 2 to the right and 3 down. Just tell us what new function you get. We'll call the new function h of t apparently. All right. Yeah, so this is just giving you physical instructions on how to move it. In the end, I want this graph to move 2 to the right and 3 down. So whatever, right, that's the instruction. Obey the rules. Exactly. You If you're not sure whether you've done it, when you're done, like graph b of t and graph your purported new function a2 t, and see if it did it, or maybe plug in a few points. Don't let me be your answer key, you know.
Oh wait, it's minus 2. Minus
T minus 2. Or related by translation.
What
do you mean by f of the
minus 2.
That means opposition, right? Alright, Amber. Did you get the second one? Do this one too. Joy, this is for you.
Do you have like a song?
A lot of people struggling with the first one. Joy, how's that second one going? You like that? Yeah? Oh, don't tell me. All right, let's come back to order. These are interesting problems, even though you guys are. We want to make sure we have really strong ground we're standing on, so we'll putting our algebra 2 skills to the test a little bit. Ananya, do you want to read off the answer? What do we say here? What would?
Yeah, e to the t minus 2 over t minus 2, and then all of that
Whoa.
minus 3.
I don't know what's going on right there, but that's my fault. Okay. Yeah, I think that's going to do it. Be careful, right? We need the minus 3 should be clear. I hope, right? Just take any function, put some parentheses around it, and then afterward be like minus 3. Okay, that's how you move a function down for you. That's clear in our minds, I think. But just make sure you're clear on that too, though. That what do we mean by moving a function 2 to the right? Well, that means take every instance of t in the equation and replace it with t minus 2, right? That's every. And if you don't believe Ananya and me, then graph this on your calculator, graph the original, and see that we did it. See that we did it. I promise. Or plug in a few points and just until you're convinced that we're right. All right. In fact, it's actually, you don't even have to go very far to see you're right on this, right? If you plug in, on the original graph, if you plug in a point like, what's your favorite point? Give me a point.
7.
7 comma,
10.
well, it's not going to be 7 comma 2. It's going to be 7 comma e to the 7th over 7, right? Isn't that a point on the original function? Let's just verify that when we plug in, what would we have to plug in on this function? If we move 2 to the right, we should be able to plug in 9, and what should we get? We should get e to the 7th over 7 minus 3, if we really did do it, right? Is that what you get?
Yeah.
All right, good. Does that make sense? Okay. This.
Should it be 7 minus 2?
Like we're okay.
Original, which is yeah.
Right 2, down 3. Gives us this point, doesn't it?
Oh, right.
X coordinate moves 2, and Y coordinate moves down 3. Okay? Right? So, and I think that's what this function outputs. Joy, help us out with the second one. We're really needing you here. Oh, we've done it? Oh. So, you could do a rewrite on this as what? And then, like, once you have that in your hands, the problem is, like, the game is up. You know, it's like no longer an interesting. It was like a fabulously interesting problem 5 seconds ago. Now not so much. But just to be clear, there's only one parabola in your life, isn't there? There's nothing special about this question. X squared should be able to be transformed into any parabola. You could rework my question. You could put any parabola you like here, and then we should be able to figure out technically, right? It'd be messy, but this one was nice. Right 1, up 6. Yeah, is the answer then. Yeah. Is there a question? Yeah.
No, I was just gonna.
Is that good? Interesting questions, aren't they? Okay, let's talk about the other rigid motion we can maybe mention, and that's reflection. The picture is worth 1,000 words, right? You understand those to be reflections of the point x, y in different directions there. And so really, if you only want to write down one thing from this slide, it'd be this. Because in a second, this is what we want to do for functions here. Carry away there. Right? How do we reflect an entire function in one of those axes? So this one makes sense, I think. So should this. I think both should make sense based on the picture. You probably have a little more experience in life doing the first thing, maybe, than the second. But I hope you see that both work. Again, you can kind of think of the second one as being a filter on the way in, that negative x. What does that do? For any given function that you have already in your possession, you have a function in your hands right now. It's called f, maybe. What are you doing if I'm applying f of negative x? Well, it means when I bring you a number, I say 5, and then you say, uh-oh, what was that? Did you say f of negative 5? Is that what you wanted? And suddenly you're outputting, instead of the values for 5, you're outputting the values from your function for negative 5, right? Well, that's exactly you flipping it across the y-axis, isn't it? Or if I bring you negative 5, you're like, oh, did you want me to take f of 5 for you? I'm like, wait, what? You keep outputting the opposite thing. Oh, okay. So we get a nice picture of that. Yeah.
Is there like a function or a formula for reflecting across the y equals x, like the line y?
I mean, I guess so. What do we call that? I mean, yeah, we do this, us finding the inverse, right?
Oh, right.
Yeah. If it's invertible,
Right.
if it's actually 1-to-1. So let's see if we can do this. What are we done here? Like now? All right. So even though we don't have a visual for this function, can we reflect it over each of these axes? Over the x-axis, what would that be? I know, it's just getting good. Right? There's always Monday? I know. Well,
So is it homework 6, right?
all right, bye guys. Have a good weekend.
Oh my God!
You're still good on homework 6, I think, though.